Sun and water are two basic elements of life. Without the sun's light and heat, without water, life is not possible. But what is good for vegetable, animal, and human life may not be good for certain construction materials, such as concrete or metal. Constant temperature changes will cause a metal roof to expand and contract, creating thermal shock. The ultraviolet radiation from the sun will eventually break down the caulking which seals the roof joints. Water may be necessary to pour cement, but is also the worst enemy of concrete. When it penetrates the mesh reinforcement, it will cause corrosion and weaken the surface. To extend the life of a roof, it's necessary to manage heat transfers, reduce radiation exposure, and eliminate water penetration. In searching for a total solution, Insulating Coatings Corporation produced Astec, a ceramic-filled, liquid-applied coating. It's a space-age solution to these century-old challenges: thermal shock prevention, corrosion inhibition, ultraviolet radiation protection, waterproofing. Astec is a monolithic, flexible coating which provides thermal insulation for tremendous energy savings, and it maintains the aesthetic appearance for years to come. To better appreciate the benefits of Astec's total solution, let's take a look at how heat transfer occurs. Heat, or thermal energy, can be transferred from one point to another by three modes: conduction, convection, and radiation. Conduction is a process by which heat flows from a region of higher temperature to a region of lower temperature within a medium or between different media in direct physical contact. Radiation is a process by which heat flows from a high temperature body to a body at a lower temperature when the bodies are separated in space. Convection is a process of energy transported by the combined action of heat conduction, energy storage, and mixing motion. When solar heat radiates over buildings, not only does the surface temperature of the roof rise well above the ambient air temperature, but the entire structure is affected as well. The sun's ultraviolet rays literally attack and break down roofing materials. Temperature differences between night and day, between rain and sunny periods, will cause roof materials to expand and contract, creating thermal shock. On metal roofs, thermal shock will cause the fasteners to loosen and eventually fall. Seams will no longer fit well enough to prevent penetration from rainfall and condensation. Corrosion finally sets in, following the ultraviolet deterioration of the joint sealers and caulking. On concrete roofs, the dilation of the structural steel mesh by thermal shock will cause the concrete to crack, allowing water to penetrate and rust the reinforcement rods. Roof problems are costly, but the true damage may be noticed in the utility bills. The increased transfer of heat to the interior of the building will require an increased use of the cooling system. Proper protection against radiant heat will have a significant impact on energy savings, maintenance, and the roof's longevity. There are two traditional types of insulation: resistors and reflectors. Resistors resist heat transfer in that they absorb heat energy and later release it to a cooler environment, usually inside the building. This is the case with fiberglass insulation. However, the transfer of heat by conduction is directly proportionate to the thickness of the insulating materials, but construction techniques and costs will limit the thickness of solid insulation used in buildings. Reflectors, such as aluminum foil under the roof, reflect heat energy away in the direction of the source, allowing for little emission of heat inside the building. But the underside of the roof is now being baked. The surface temperature of the roof will stay hotter longer, leading to the obvious problem of deterioration. Although both types of insulation provide varying degrees of protection against heat transfer, none of the traditional materials provides any protection to the roof against ultraviolet degradation, thermal shock, color fading, and corrosion from water penetration. After years of research, Astec was developed by Insulating Coatings Corporation as a total solution to roof protection and heat transfer reduction. An Astec roofing system is both a methodology and a full energy management product line. A simple comparison of Astec to resistors and reflectors will highlight its advantages. It's obvious that Astec provides many qualities that resistors and reflectors cannot, including thermal shock prevention, waterproofing, aesthetic appearance, and roof repair savings. Two important factors to consider are reflectivity and emissivity. Reflectivity is the extent to which a surface reflects radiant energy. Emissivity, on the other hand, is the rate at which absorbed heat is re-emitted. If the ambient temperature reaches 32 degrees centigrade, your roof temperature can easily rise between 45 and 60 degrees centigrade. Anywhere from 75 to 90% of the heat buildup in a structure comes from the roof, mainly because most roof materials usually have low reflectivity and low thermal emissivity values. Resistors will absorb the heat until the insulation material reaches a temperature higher than its environment. Most of the heat will flow through the ceiling by conduction and into the living space. Reflectors with high reflectivity and high thermal emissivity prevent the heat transfer and minimize the radiation into the building, but they create a much more severe oven effect by reflecting the majority of the heat to the underside of the roof. The roof is now being cooked on both sides, creating considerable thermal shock pressure on the roof structure. Astec uses a total solution to keep your building cooler and to help your roof to remain in good condition. Astec will reflect between 80 and 85% of the radiant heat energy off the surface of the roof. The remaining heat energy, a mere 15%, is quickly re-emitted due to Astec's high thermal emissivity. To demonstrate the protective qualities of Astec and see some actual temperature differences, we can use this model of two roofs, one coated with Astec, the other without. Each roof is connected to its own thermometer. The light shining on the roofs is 600 watts. In less than 2 minutes, the uncoated roof soars to approximately 150 degrees. The Astec roof reaches its peak at about 100 degrees.